We're going to look at this next problem in stages. I'm going to ask you to pause the video and try some things on your own, but I'm not going to ask you to work the entire problem at once. We'll do it in some stages. So the first thing that I would like for you to do is identify P and Q, and from that, go ahead and find all of the possible zeros. Remember that you have to have every P value divided by every Q value. Pause the video and come back here to see how you did. All right, so you should have identified P as 12 and written these factors, and then Q is 3, so we have factors of 1 and 3. That means we're going to have two sets of numbers, one with P over 1, which will just be the P value, and then another one with the P value over 3. So you should have gotten all of these factors. Now, we can whittle down this list just a little bit by recognizing that some of these factors are duplicates. 3 divided by 3, well, if we simplify that, it's 1, and that's already accounted for. So I'm going to cross that one out. Not because I know it isn't a solution, but because it's already part of my list. The same thing with 6 over 3, because that's 2, and 12 over 3 is 4. Now, what I'd like for you to do is go ahead and test using synthetic division and find a 0. Hint, start with testing a 1. Come back here to see how you did. All right, hopefully you took my hint of starting with 1, and so whenever you take this one, synthetic division by 1, notice that we had 5 terms here. I didn't mention that at the beginning, but there would have been no other way to factor this polynomial except for the method that we're using right now, because we have 5 terms and we don't have a method for that. We only have up to 4 with grouping. All right, so once you did 1, you should have seen that you got a 0, and so yes, that is a solution. So we'll want to identify that as our remainder of 0, and then we have constant x, x squared, and x to the 3rd. The next step is to rewrite our partially factored form, remembering that this k value is the opposite of the factor, and then continue factoring. I would like you to try that, and I'll give you a big hint. You're going to have 4 terms left in your polynomial, and that should lead you to a particular type of factoring for 4 terms. Give it a try and come back. All right, so you should have identified x minus 1 as your first factor, and then rewritten the rest of the polynomial, combining our variables and our coefficients and constants together. Once you do that, you'll notice that with 4 terms, we should use the grouping technique. So group it into 2 pieces by putting brackets around the first 2 terms and the last 2 terms, and find your greatest common factor between just those small groups of 2. GCF of x squared leaves me with 3x plus 1, and then a GCF of negative 12 for the second half also leaves me a 3x plus 1. This worked. I have 2 identical parentheses. Now I can combine my like terms, my 3x plus 1, and use the x squared and the negative 12. We need to investigate this term right here because it has a squared on it and see if we can factor further. I see 2 terms and subtraction, so if that's the case, I need either perfect squares or perfect cubes. And while x squared is a perfect square, 12 is not. So we are not going to be able to use that factoring technique, so we are done with factoring and we're ready to move to solving. We're going to look at solving together because a couple of these are going to look a little bit different than the ones we've done so far. So we're going to set each of the factors equal to 0, just like we've done previously. X minus 1 equals 0, x squared minus 12 equals 0, and 3x plus 1 equals 0. This first one is similar to what we've done previously, so move the 1 to the other side and get x is equal to 1. X squared minus 12 equals 0. For this one, we still have an x squared that we need to deal with. I notice that I don't have a middle term though. I have an ax squared and I have a c, but no bx term in the middle. So that leads me to using the square roots method that we learned last 6 weeks. We could also use quadratic formula on this if you would like to, or even completing the square. We already know that factoring won't work. And because we are expecting something with maybe a square root in it, graphing won't work either because we would get a decimal that we couldn't change to a fraction. So let's take a look. In order to use square roots, we want something squared on one side and everything else on the other. So x squared is a perfect square. We'll leave that on the left, but we'll move the 12 to the right because it's not a perfect square. Now, in order to solve for x, I need to undo a squared. So I undo that by taking the square root of both sides, remembering that I need a positive and negative on the square root of 12 because I don't know if it was two positive things that made the x or two negative things that made the x. Once it's squared, that information is gone. The x squared and the square root cancel, and that's going to leave me with x on the left. On the right, plus and minus square root of 12. This is our solution, but it's not in its most simplified form. Remember that even if it isn't a perfect square, we need to look for hidden perfect squares. So we'll do a factor tree, 3 and 4, and 3 is prime. And then 4, you might recognize that as a perfect square. In that case, you can stop here, or you can go and do 2 and 2. And then now we have a pair that we can pair up under a square root. We will be left with a 2 on the outside. We can't do anything about the 3 that's left under the square root or radical symbol. So we can rewrite square root of 12 as 2 square root of 3. So this is actually two solutions, 2 square root of 3 and negative 2 square root of 3. You will most likely need to report it as 2 separate solutions in your homework assignment. This last one is just a two-step equation. After we move the 1 to the other side and make it negative because we've subtracted from both sides, we want to divide by 3 and we'll get that x is equal to negative 1/3. Let's take a look at this real quick. X equals 1, well, we knew about that solution because that's the one that we found when we used synthetic division. Our negative 1/3, well, that was definitely one of these solutions, the possible zeros here. However, we didn't come up with the square root one. But remember, we are using the rational roots theorem that says that all of the possible rational roots can be found by this method. If it has a square root, it's irrational because you are not able to write it as a ratio, as a fraction. It's going to give you one of those ugly decimals if you put it in your calculator and convert it to decimal form. So that's the reason that we could not find this one as one of our possible solutions. It only finds rational roots.